Welcome to qnawire.
All right, in question 109, we're asked to calculate the number of kilowatt hours of electricity that are required to produce 1.0 times 10 to the third kilograms of aluminum by electrolysis of aluminum 3 plus. So we're going from aluminum 3 plus 3 electrons, and we're forming aluminum metal in this electrolysis. And we're applying a voltage equal to 4.50 volts, but we're only going to get a 45% efficiency. So I'm going to start this by using my mass of aluminum that I want formed here. So I'm going to start with 1 times 10 to the third kilograms of aluminum. And I'm going to set up what I call train tracks, but they're just fractions multiplied by each other to do my conversions. So the first thing is I need to get those kilograms over to grams. So 1 kilogram is 1,000 grams aluminum. So that cancels, and I have grams of aluminum. Now I can go from grams of aluminum to moles of aluminum using the molar mass. So grams of aluminum cancel. Now I have moles of aluminum. Now the connection between the substance and voltage or amps or any of that is going to be your electrons. So I'm going to want to convert from moles of aluminum over to moles of electrons. And in this, because we're going from aluminum 3 plus to aluminum, there are 3 moles of electrons that are transferred per mole of aluminum. So for every 1 mole of aluminum, I'm transferring 3 moles of electrons. So that gives me electrons. Now, once I have electrons, I can use Faraday's constant in order to get from electrons over to energy. And so I'm going to use 96,485, and I'm going to use the unit of joules per volt mole of electrons. This is one way that you can break down the units of Faraday's constant, because that's going to give me joules and volts, and I know my volts, so that's going to help me get to where I'm trying to get to. I also happen to know that I want a watt hour, but I know a watt is equal to a joule per second. And I also know that a kilowatt would be 1,000 watts, right? And a watt hour is a watt basically times an hour unit. So this is what I'm trying to get to. I'm trying to get to kilowatt hours in my units. Right now I have joules over volts. So to cancel out those volts, I was given the voltage. It's going to be 4.50 volts. So now my volts cancel and I have joules, but I want watts, which are joules per second. And so I'm going to take this, and I also want it to be kilowatt hours. So the next thing I'm going to do is multiply by 1 hour, which is 3,600 seconds. Okay, now by doing that, I now have joules per second, which is a watt, times hours, which is a watt hour. And finally, I want kilowatts. And so I know that for 1 kilowatt is going to be equal to 1,000 watts. This fraction is kind of where I think most people would have a difficult time, but you really just want to break down your units. You know that you want joules per second, and you know you also want it times hours, and this fraction they're equal to each other, so you can multiply by this fraction. So that gives you joules per second, which is the watt, times hours, which is the watt hour. When I put that all into my calculator, I get 13400, so 13,400 kilowatt hours. But then I have to take care of the issue of the efficiency. And efficiency is basically, it's very similar to a percent yield. What it tells me is how much, so I know I had 45% efficiency, and what that's telling me is how much of what I should have made did I make. And so what I need to calculate is how much, I basically want to calculate how much should I theoretically be shooting for, knowing that I want to actually make 13,400. You could have done this back up here with, like, when you're talking about the amount of aluminum, you could have put in your efficiency here and solved for the amount of aluminum you're shooting for. I'm doing it at the end, but you could do it either place. And so when I then solve for the theoretical amount, I'm going to get 3 times 10 to the fourth kilowatt hours.